Hello guys, I'm Sudarshan Koirala and welcome back to Data Science Basics. In this video, let's see how we can extract image and image information from the PDF using Unstructured. Right, I have been creating videos in Unstructured. The first one is what is Unstructured on a higher level, and the second one was how to extract the table data from that particular PDF and summarize it with Llama 3 via Ollama. And many of you mentioned in the comment section that you want to see a video where we can extract the information of image from the PDF. So this is how the video will proceed. First, we will use the PDF and we will pass the PDF into the partition PDF of Unstructured, and we will extract the image information. Right, when we do this initial part, there is not all the information being extracted, so we will modify the code and we will also extract the images separately and also the image information. Right, and at last, as a bonus, I will show you how to explain the image using the LlaVa via Ollama and LangChain, meaning that we are going multimodal here. So we will pass the image into the LlaVa LLM and then that will explain what the image is all about. Let's get started. Okay, before going into the code, here is the YouTube stops, and inside there is data cleaning. Inside here there is this unstructured image extraction from PDF. So you can clone this repository and then continue watching with me. So I will open the terminal here. As you can see, I have already cloned this particular repository. I have created the virtual environment and activated it so that the packages are isolated only for this particular virtual environment. That is really good practice if you are using Python. And then I'm going inside the data cleaning, as I mentioned you in the GitHub page. And here, these are the things that are inside this data cleaning folder. And now I will open this in our VS Code, right? So VS Code is here. Let me get the VS Code from another window. So yeah, this is the VS Code. We are going to use this unstructured image extraction page. So I will make this bigger. Here are some of the links I have been mentioning in all the videos. Please go there if you want to know more information about the Unstructured. So in the setup, here we are first installing the Unstructured library, right? If I do shift enter, this will take some time, and then you might be thinking, what is this percentage capture? I have been explaining this in my previous video also, but this will capture all the outputs that is shown below here. It is not, so it is just captured inside it. So our notebook looks clean, and the watermark is here to print what version of Unstructured or different packages we are using in this particular project. So it's easier to track so that if something doesn't work, we can just come back and say, okay, which version of that package is being used during this time. So it is now installing all the necessary packages here. After this, here is the another thing called warning control, because I don't want any warnings to be shown here. So this is just the optional one we can run. So it is taking some time to install the necessary packages. So after this is installed, what we can do is this importing things here, and these are the other import that we need to do. I have been explaining this before also, but mainly we are using this partition PDF in order to explore different things, and these are for the Unstructured client. But in this particular video, I'm not going to go through that, but if you are using the API of Unstructured, then we will be using this, right? So yeah, all the things are being installed now. So I can run this, and then I can import necessary class and functions from here, and I can load the watermark from here. Let me first see that all of things are being imported. I'm showing all this step by step because some of you mentioned that it's quite difficult to follow each and every step if you already run the shell. So I'm going to run it as I demonstrate it. So if there is some errors there, I can explain you what it is all about. So yeah, this is the loading the watermark. I can run this. So you can see that the JSON version 2.0.9 is shown and Unstructured client is shown, but here we don't see any Unstructured, right? So you need to be careful. For example, if I go here and in here, I can just import, let's say, Unstructured. So if I run this, it is imported Unstructured. Now if I run this, it will be showing us the Unstructured also, meaning that how this watermark works, is you need to be installing something already in the beginning, and sometimes it does not show the unstructured. So if you want to show all things at once, then just import the main package first and it will be shown here. I hope now that is clear. So yeah, the first part is setup part is done. Now we can go to the initial exploration. So this one I will not go through this because it is just printing what are the different package contents. And the next one is, as you can see here, we have the data inside this data folder, right? In the data folder, I have this GPT for all PDF paper. I have been using the same PDF for all these videos here, right? So I will just go here. I will close this, and I'm just importing, partition PDF, which I have already done here, but just to show you in cell by cell, it's easier to explain. And then we are having the file name as data/GPT for all PDF. We are passing that file here, and everything is taken care by this partition PDF. So what happens if we do this? I have been explaining this in my previous videos, but just to make sure for all of you. So here, if I go and see the elements, so there is the length of the elements, 134 elements is being extracted. And if I go here, I can see the contents of that particular elements, right? I'm printing here elements and it is shown here. If you just click this text editor, it will show you all the elements here, because that is being truncated in the shell here. So if you want to see what are the unique elements being extracted, so here it is just narrative text, title and uncategorized text, but we want to have the information from the image also, right? So if you are doing the normal partition PDF implementations without any strategy being set up, it will not show here all the elements that it is fetching from that particular PDF. So how to achieve that? I have written here, you can just go here and read. We don't see image table information. Okay, we don't see the image, right? So I can say here, image information is not extracted. So we need to use the different strategy, and we need to use high res strategy. There are different strategies. You can just go and look here. And one thing to mention now, that we are using different strategy, meaning that we want to extract more information from that particular PDF. Meaning that under the hood, Unstructured needs different packages apart from the previous one. So you might be facing some package installation issues here. It will maybe complain this package is not installed, that package is not installed, and so on, based on the machine. So I'm using this in Mac, but you might be using Linux or Windows and so on, right? So here are two links that I find it helpful. This one is from the Unstructured website itself. So it has recommended you to install some packages in your system, so it is able to extract those informations. And if you still face some issues, there is the link in the Stack Overflow. I find it helpful when I set up my machine, so you can also go through that if you get any issue. If you don't get any issue, then that's great. So here you can see I am explaining from Unstructured partition PDF, and elements partition PDF, and here is the high res, right? If we run this now, so it says here high res, okay, cannot import name partition PDF from partition. And this, why it is not installing is because from unstructured.partition import this. Let me see what is happening here from Unstructured. Okay, what was the first one we used? From unstructured.partition.pdf, right? It was you can even use auto, but I need to use .pdf, right? So now I'm providing the strategy high res. So when we use the high res, so as you can see here, it is going to be reading the PDF file this, and many different packages will be used under the hood to extract more information. And you can see there is this logging also being shown here, and it is using OCR with Tesseract to extract the information from this particular PDF. So depending upon your PDF, how big it is and how many different elements there are, some of the PDFs might contain images, figures, tables, and so on. It will take time based on that. So now it is being extracted. So if I just go here and print now, you can see first we have what we have before. Where it is here. Okay, here you can see there is just narrative text, title, and uncategorized text. But now just using the high res, what we were able to do is we were able to get the image, footer, header, table, and unstructured text is there. list item, figure caption, and all the information that is in this particular PDF is being extracted with this high res strategy. So now we are focusing on the image, right? So if we go here and see the images, it says here none, but there are already some images. So you can see there are 6 different elements. It is not shown here, or you can even print length. It is not shown here in 0 because in 0 there is nothing. But if I have already run this once, so I know from where we can get some information. So if I not 6, but it is 5 because it starts from 0 in Python. So you can see there is GitHub repo growth and something is being extracted from this particular image. So if you go to this image, where is the GPT for all, you can see this is from where it is extracting the images: GitHub repo growth, and there is GPT for all, Llama, Alpaca, and so on, right? So here you can see there is GitHub repo growth, there is UMA, Alpaca, and so on. So it is getting the information from that particular figure or graph, whatever you want to call it. So that is using this just high res, right? I will show you now a little bit more advanced way. So there is another way. What we can do, if you want to know what are the different arguments or parameters that goes inside the partition PDF, just write partition PDF and 2 question marks. You can see the signature here. So you can see what are the different parameters you can pass into this particular class, right? But if I go down here, now what I am saying here is because I want to now also extract the images from this PDF. Before we have the information of the PDF, but now I want to also extract the images, right? I say here path is images, but before this I will remove this image folder here because I have already run this one. So I will remove this images folder. There is no image folder here. I will show you side by side here. So I'm saying okay, images, because I'm going to work in this particular path, but you can just provide any path you want from where the images will be stored. And I'm saying raw PDF elements here using the same partition PDF. I'm passing the file name. Extract images in the PDF. I can pass true so that it can extract the images. Strategy is high res. Remember that we need to use the high res strategy. And infor table structure is true. We also want to extract the table information, but you can just make it false if you want. So this only applicable if strategy is equals to high res, and this extract image block output dir equals to path. In order to use this particular argument, you need to have the strategy as high res, otherwise it will not work. So these are the things from where you can get. This is the information that I said you can get, but if you want to go in depth and see what are the different things you need to pass, or you can go to this particular link. If you click this one, you can see all the information from the code is being provided, source code. And if you scroll a little bit down, it is explaining all the different parameters here with what is the file name, what is file, what is strategy, what are the different languages it supports, what is the metadata info, and so on. So this is how you can get only applicable if strategy equals to high res for different things. So you need to go step by step, knowing what the code is doing under the hood and then applying that into your code, right? So once I run this, what will happen now? If I run this again, you can see the same thing is happening again. That is happening up here, right? All the information, not this one, but this one. All the things are happening, but now here the image folder will be created, and all the images from this particular PDF will be dumped in that particular folder called images. So you can see here there is now images being created. If I go inside the images, there are the figures here. And if I go inside the figures, so these are the figures from this particular PDF. So now let's display. I have already displayed here, but this code, let me close that first. So here with this code, what we can do is I'm saying go to this image folder and display all the images. So I will just run this here, and you can see it is extracting how many? 1, 2, 3, 4, 5, 6 different images. So this one is one image that it extracts. Second one is going inside it. Now it's extracting one at a time, and then at last it is extracting that 4. Now what we have is we also have all the images that is being used in this particular PDF. We also have the image information also being extracted from this particular PDF, right? So now let's go multimodal, meaning that we will pass this image and ask the LlaVa model to explain us what is this image about, right? So for that, what we can do is we can use the LlaVa from the Ollama. Again, now if you are new to Ollama, I'm not going to go and explain you what is Ollama and so on, but I have the playlist here. You can just go through this playlist. You need to first install Ollama and make sure it is running in your machine also. And we need to first install the necessary packages. So I'm installing LangChain because we are going to use Ollama and LlaVa via LangChain. LlaVa is going to use via Ollama and Ollama is going to be used via LangChain, right? So yeah, this will be installed and now I can import the Ollama from here. So again, here is the question mark things which gets it's the best way to explain or let's say see what is inside this particular class, right? So here it says Ollama and you can see all the different parameters or argument, what you want to call it, are inside this Ollama. And you can see here it is by default using the Llama 2 and this is the localhost 11434 where the Ollama is being listened. So if you click this one, I want to show this because many of you mentioned in the comment section why is this error showing in my machine. So when you run Ollama, make sure that Ollama is running. So whatever question that I have been seeing in my other YouTube videos, the question is the same. It is not listening to port this Y because you are not running Ollama. So first run Ollama or open Ollama in your machine. Make sure it is listening in port 11434. If it is not, uninstall it, again install it and make sure first it is listening to this port, right? So now I can say LLM equals to Ollama model LlaVa 7b. I can use that because I have already pulled that particular model from Ollama. So if I do here Ollama list, you can see that I have LlaVa 7b, which is 4.7 GB in size. It is already being installed and I have Ollama installed, meaning that I can use LlaVa with this thing here. So LLM equals to Ollama. I am passing the model as LlaVa. So I will run this one. And you need to have peel installed here. I'm showing you this because when you run this next line of code, sometimes if there is no peel installed, then it will show the error. So I am using the 10.3.0 version. And now the next thing what I'm doing here is convert to base 64. I'm converting the peel images to base 64 encoded strings and then the plot image base 64. So if I run this, you can see that I'm just plotting this with this particular code. And next what we can do, I'm using this because now I'm going to pass this image because in other images, if you go here, we don't have that many informations here, right? It is just a random image, but in this one we have some information so that the LlaVa model can give us some input or some output out of it, right? So we want to have LlaVa explain what is this image all about for us. So I have already run this here. So you can see LLM with input image context. So what I will do is I will first run this. So we have this image here and here you can see this is the information that is already being provided when I run this code before. So what I'm doing here is LLM with image context, LLM.bind, and I'm binding these images and I'm passing image B64 because here image B64 is we converted to the base 64. So we have the peel image. Okay, I think it's easier to explain here. So this is the file path I'm providing, image folder, this 46 image. Peel image is image.open file path. So now we have this peel image. I'm passing that into this convert to base 64. So convert to base 64. So that is being converted. And now this image B64 can be passed into the image.bind and then we can invoke that. So I'm saying here, explain this image. Right, so it is showing here, okay, the image shows a line chart representing the growth of GitHub repo over time. So if you run this again, it will show you maybe some other information because that's how LLM works. It does not provide you the same information each and every time. Sometimes you can get okay answer, sometimes you get great answer, and that is when you can ask, have your prompt optimization techniques being implemented. So you know, if you ask certain types of question, it will give you the right answer. So yeah, it is taking some time in order to go and extract the information from this image. So yeah, here is the image. The image is a graph showing the growth of GitHub repositories over time. This. You can just go here and see. But yeah, this is how you can extract the images. So what did we do? Let's just recap first. And before going there also, let me see if I explain you all the things or not. So we did this, we did extract the image information. Yeah, let's summarize now. What we did, we have the image or the PDF, we passed that into the partition PDF. We went through 3 different strategies: without high res, with high res, and next one with high res, and also extracting the images and saving it into a folder. And then we just passed that into the LlaVa via Ollama and LangChain to explain that particular image. So now I hope it cleared your questions, how to extract the image and image information from the PDF. Thank you for watching. If you are new, subscribe. I have more educational videos in the pipeline. I will be still creating some videos with Unstructured. So yeah, thanks for watching and see you in the next video.